All right, in this next example, we're just going to find each indicated measure. For this first one, we're going to find the arc length of arc AB. So basically, what is this going to be? There's two ways for us to find the arc length of something. We can just do theta times r. In this case, theta will be in radians. We're going to be learning how to convert degrees into radians, so feel free to check out example 4. We're going to be doing that in this example too. But basically what a radian is like where the angle at which the radius is going to equal an arc length. So for example, like imagine if 45 degrees, the radius of something, if it was like 2, it would be the same as like this. So it's kind of like, that's just what a radian is. Okay, anyways. So that's one of the formulas, or we can use theta over 360 times 2 pi r. We would want to simplify this first, and this is only if theta is in degrees. Okay, so there's two different ways we can find the arc length of something. Okay, let us do that. So what is the arc length of AB here? Okay, let's go ahead and try converting something into radians. So here in this case, the arc length of arc AB is going to equal theta in radians. So to convert theta into radians, we're just going to simply do 60 times pi over 180. The formulas for it are right over here. Okay, so let's go ahead and simplify this. So 60 times pi over 180, we can cross out the zeros, and then we're going to be left with 6 over 18 pi. Simplify this, so we're going to get 1/3 pi, but 1 times pi is just going to be pi over 3. So right now, we have this right over here, our theta. Our theta equals pi over 3. And then to find the arc length of something, we're just going to take that in radians times the radius. What is the radius that is given to us? It is 8 centimeters, so times 8. So it's just going to be 8 pi over 3 is our solution here. That is our solution in radians, which is cool to give. But if you want an actual value, let's just pop it into a calculator. So 8 pi is just 3.14. It is the ratio between the circumference over the diameter. It is always going to be that 3.14159 blah blah blah, right? Oh yeah, I already did that in the previous video. My bad. Okay, anyway, so 8.377 is going to be the arc length of AB, which is also equal to 8.377. What is it? Centimeters. Fullness. Sorry, I feel like I'm talking too much. Okay, let us go on to B. Ooh, no, that's not what I wanted to do. Sorry, let me do that again. What is B? What does B say? Find the circumference of circle Z. Okay, that's easy. To me. Okay, and then let me delete this. Sorry, feel free to skip ahead. Okay, the circumference of circle Z. So the circumference again is that the entire circle, like the length of the entire circle. And to find that, remember that the circumference is equal to 2 pi r, which is 2 times pi times the radius. So we need to find the radius here. But what is given to us? We are given a central angle of 40 degrees, and we are also given an arc length of 4.19 inches. So if we wanted to, let's use this formula. We already know an arc length, and we know what degree is given to us. Let's go use this arc length formula. So the arc length which is given to us. So 4.19. 4.19. Golly, sorry. 4.19 is going to equal theta over 360. We do know what theta is, thank goodness. In degrees, it is 40 degrees. So 40 over 360 times 2 pi r. Let's go ahead and simplify this. We have 4.19 equals 4 over 36. But 4 over 36 can also be written as 2 over 18, which is the same thing as 1 over 9. So now we have 1/9 times 2 pi r. I'm going to multiply 9 on both sides here. So that way we can start isolating this 2 pi r, because 2 pi r is the circumference. So 9 times 4.19 is going to give us 2 pi r. So 2 pi r is already the circumference, so it's whatever 9 times 4.19 is. And what is that going to give us? 9 times 4.19. 37.71. So 2 pi r, which is the circumference, is going to equal 37.71. What is the measurement here? Inches. Fullness. All right, last one. Let's move this over here.